Hello, math students. Welcome to Module 4, Expressions and Equations. This is Lesson 7, and it is called Factoring Expressions. Our goal for today's lesson is, today we will learn how to write and model expressions using the distributive property. The question that I want you to think about in this lesson is, how do you use the GCF and distributive property to write equivalent expressions? Okay, so some things to know. I am hoping that a lot of you have already heard in the past with your math what a GCF is. But just in case you haven't, then I'll do this little quick lesson to help you remember. A GCF stands for greatest common factor. And what a greatest common factor is it's a value that two numbers have in common, but the value is the biggest one that they share in common. And so what we do to figure out what the GCF is we have to list all of the factors of the numbers being compared, and then we have to find the largest number that they have in common. So GCF is the largest number that two numbers have in common. So if we do this, an example of finding the GCF of 12 and 18 looks like this. We know that the factors of 12 are 1 and 12, 2 and 6, 3 and 4, and 5 does not go in, but we already said 6 does because 6 times 2 equals 12. 7 does not, 8 does not, 9 does not, 10 does not, 11 does not, but 12 does. So now we have found all of the factors for the number 12. And then what you have to do is you have to find all of the factors for 18. So we do it the same way. 1 is because 1 times 18. 2 is because 2 times 9. 3 is because 3 times 6. 4 is not. 5 is not. 6 is because we just said 6 times 3 equals 18. 7 is not. 8 is not. 9 is because 9 times 2 is 18. 10, no. 11, no. 12, no. 13, no. 14, no. 15, no. 16, no. 17, no. 18, yes, because the number is 18. So now we have found all of the factors for the number 18. So now your job is to go and find which one is the biggest one they have in common. So 1 and 1 are in common, 2 and 2 are in common, 3 and 3 are in common, 4, no, 6 and 6, yes, 9, no, 12, no, 18, no. So the one they have in common, that is the largest one that they have in common, is the number 6. So we can now say that the GCF for the numbers 12 and 18 is 6. And we have found the greatest common factor that they both share. All right, so that's how we find GCF. The next thing we have to remember or we have to know about is what factored form is. And what factored form is when you find the GCF and you factor it out. Now remember, a factor is an amount that when multiplied by another amount, it gives you the answer. So when you're factoring something out, that means you're pulling out that number and you're leaving what the other number it took to multiply it to get the answer. So what we do is we try to find the GCF for the two numbers that we're looking at, and then we divide them out or we factor them out. So the way that this looks is we have an example right here of 20x plus 5. So what we have to do first is we have to find the GCF. So we're looking for the GCF of 20 and we're looking for the GCF of 5. Well, the factors of 20 are 1, 2, 3, no, 4, yes, 5, yes, 6, no, 7, no, 8, no, 9, no, 10, yes, 11, no, 12, no, 13, no, 14, 15, 16, 17, 18, 19, up, and 20. Now we found all of the factors of 20. Now we have to find all of the factors of 5. So 1, yes, 2, no, 3, no, 4, no, 5, yes. Okay, we found all of the factors of 5. So now we have to find the ones that they have in common. So let's take a look at it. Right here, they have 1 in common, and they have 5 in common, and that is it. So the GCF for 20 and 5 is 5. So we know the GCF is 5, so that is the number we're going to factor out. And remember, factoring means that you divide it from the original expression. So our original expression right here is 20x plus 5. So what you're going to do is you're taking 20x divided by 5. Remember, the fraction bar means to divide. And you're also taking 5 divided by 5 because that's what we call factoring out. Factoring out means you divide it out of the original expression. The original expression was 20x plus 5, so we're dividing both terms by 5, and this is what we have left. 20x divided by 5 leaves me 4x, and 5 divided by 5 equals 1. But then what we have to do is we have to show what we did with the GCF so it sits outside. Okay? Does everybody see what I just did? So when you are trying to find factored form, you find the GCF and it sits outside. Then you make parentheses and you divide the GCF from your original expression, and what is left goes inside the parentheses. So 20x divided by 5 is 4x, plus 5 divided by 5 is 1. And so now we know that the GCF was 5, and what is left over from factoring it out is 4x plus 1. So this right here is called factored form. Okay? And you need to know that information. So hold on to that, please. Okay, the next thing that you need to know is you need to know what we call expanded form. Okay, and expanded form is a little bit different because what expanded form shows us is it shows how the terms are separated. So expanded form says separate each part of the expression. So if we take a look at the parts of the expression, we have this part right here, and we also have this part right here. So there's two terms, so two parts of the expression. So if we're going to expand that out, what it means is, how many x's do you see? I see 20. So if you're doing expanded form, you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 x's, because that's how many we see, right? Plus 5. Okay, so that's expanded form. Another way to show it would be if you went 20 times x plus 5. That's another way to show expanded form. Okay, so expanded form just means you're breaking up each set of terms that you have. You could also show it with the 20 x's, and then you could also do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, plus 1, plus 1, plus 1, plus 1, 1, 2, 3, 4, plus 1. And then that's like uber expanded form because everything is spread out, okay? And so that gives you another idea of what expanded form is. Expanded means you're just taking it out of standard form. This is standard form right here, okay? You're taking it out of standard form and you're spreading everything that you've got out, okay? All right, and then standard form, which I just said, standard form is the expression written in the most simplified terms. So how many x's do you see? I see 20 x's, so I would write 20 x's. How many ones do you see? I see 5 ones, and so my standard form would be 20x plus 5 because that's the most simplified way that we can write it. You need to remember that standard form typically means that the number is written in the most concise, simplified way that it can. Okay? All right, today you will learn how to write and model expressions using the distributive property, which is what we did right here. The distributive property really is factored form. That's what it is, okay? So whenever you see factored form, you know that you are going to do distributive property. That means I have 5 groups of 4x plus 1. So that's the distributive property. How do you do distributive property? You have to find the GCF. After you find the GCF, you have to factor it out, and then you have factored form. Okay? All right, kiddos, that's all I have for you in this lesson. Oh, we forgot to answer the question. How do you use the GCF and the distributive property to write equivalent expressions? Well, you just do what we showed you. Here is the original expression. We find the GCF. We factor it out, which means we divide it out, and we have another form that means the exact same thing. Because watch, kiddos, what if I have 5 4x's plus 1? Let me show you this. This is pretty awesome. So in my tape, right, I have 4 x's, 1, 2, 3, 4, and I have a 1. That's what this says right here. But this GCF tells me how many tapes I have to have. So I actually have 5 of these tapes that look just like that. So I have 1, 2, 3, 4, and 1, 1, 2, 3, 4, and 1, 1, 2, 3, 4, and 1, 1, 2, 3, 4, and 1. So now if you count them all, 4, 8, 12, 16, 20, ta-da, 20 x's plus 1, 2, 3, 4, 5 plus 5. So this picture of tapes shows you what the expression actually looked like. So it's pretty cool. We're going to play a lot with this when we get into class. Okay, kiddos, that's all I have for you today. Talk to you soon. Bye!